So, okay. I'm going to continue with electron. Don't pay attention to what I'm saying, guys. I'm recording a video for you. Okay, so we're going to continue with electron configuration, but now we are going to use the information that we have from the electron configuration just to get information about the position of the element in the periodic table as well as the chemical and physical properties, because you already learned that depending on the group that the element is placed in the periodic table, you're going to have like certain like chemical and physical property. Mirama, what are you talking about? Because we don't understand that. For example, you were learning during the last lesson that the alkali metals, they are located in group 1, and all the elements that are located in group 1, the color is a silvery like color. They are soft. Another physical property, they are so soft that they can be cut with a piece of plastic knife, and that they are highly reactive. They react with oxygen, they react with water. Those are chemical properties. Now, you were learning also in that lesson that was talking about the periodic table that the transition metals, the ones that are located in the center of the periodic table, they are less reactive than the metals that are located in group 1 and group 2. Metals that are located in group 1, alkali metal, alkali earth metals, they are soft. Now, the metals that are in the transition groups, they are not soft, they are ductile, they are malleable, and the reactivity is very low. That's why we use iron, we use zinc, and we use some of them nickel just to build different structure. In addition to the alkaline earth and transition metals, you learn about the halogens, the ones that are in group 17, and you learn about the noble gases. And you know that the noble gases, they are inert. And inert means that they are not reactive. Why? Because they have all electron in the last level of energy. See how the electrons have to do with the chemical properties, and I'm gonna show you that here with this video. How, Ms. Ramos, is the electron configuration related to the periodic table, related to the chemical property of the elements? And we're gonna start with calcium. Calcium atomic number is 20. You know that the atomic number is the number of protons, but since the atoms, they are neutral, you're gonna find in a neutral calcium atom, you're gonna find 20 electrons. Are they gonna be organized, all of them in the first level? No, you learned that like 2 lessons ago. My first level has only one sub-level, orbital S, and in that orbital, I have only a space for 2 electrons. Remember that every orbital has space only for 2 electrons if they are spinning in the opposite direction according to Pauli exclusion principle. So my second level with 2 sub-level, S and P. In the S, as you will know, I'm going to accommodate up to 2 electrons. On my P sub-level, I have 3 orbitals in which I can accommodate 6 electrons. See that? Can I have a D or an F orbital in the second level? Impossible, because the second level has only 2 sub-levels or 2 sub-shell, S and P. Third level, with my S2, my P six, and this is when you have to start looking at the diagonal diagram. Why? Because remember that S and P, they have less energy than D and F. So before filling a p orbital, electrons, they're gonna fill an s orbital. Before filling a d orbital, electrons, they are going to fill an s and p orbitals. Before filling a d orbital, electrons, they're going to fill an s and p and a d orbital. And that's why you have to follow the diagonal diagram. The 4s orbital has less energy than the 3d. Remember that you have to accommodate 20 electrons, so I'm going to count 2, 4, 10, 12, 18, so it's 4s2 instead of 3d2. But you already know about that. See? And that's why I was recommending when you are writing electron configuration just to create your or get your diagonal diagram before starting writing the electron configuration. Okay, Ms. Ramos. Now, with this information, let's say that we don't have a periodic table. What is the information that we can get from there? So you're going to look at the ending. 4s2. What is the information that you're going to get from there? By looking at the number of electrons in the s orbital, 2, you're going to find the group number. So calcium is located in group 2. The 4 is giving you the level of energy and period number. So period number, which is 4. Meaning that calcium is located in period 4, group 2. Ms. Ramo, what other information I can get from there? Since you have only 2 electrons on the last level of energy, balance, a number of valence electrons, okay, by the way, the valence electrons are the ones that are involved in bonding. It's super important for bonding. So calcium has only 2 valence electrons, 2 electrons ready for bonding. Beside that, Ms. Ramos, what is another information that I can get from there? Since the ending is S, okay, is a representative metal or representative element. Okay, elements that electron configuration ends in S or SP are classified as representative elements. When the ending is D, then the elements, we call that the D block, they are classified as transition elements. D or F, but the F block is gonna be composed by the lanthanides and actinides in there, which are the 2 rows that you have at the very end of the periodic tables. Those 2 rows, the lactanide and actinide, they are part of the transition elements, but they are gonna end, see, the electron configuration is gonna end in the F block, okay? Or when you look at the electron configuration, you have the F orbital there in the last level of energy. Show you the diagonal diagram. See that before completing the 4D, 5S is gonna be completing. Before completing that one, see, this one is gonna be completed before completing that one. And that's why you go from 6 to 5D, because see, that one was completed before and the 4F, okay? 4F, because you were following this. The ending was this, they were completing this first, but after the 4S, the 6S2, 4F14 was completing, 5D10 was completing before completing the 6P. And why, Ms. Ramos, you were not saying that the D and the F, they have more energy than the P? Yes, but remember that we're talking about level of energy. So look at the 4. See, the 4f, even though it's an f orbital, is gonna have less energy than in 6p. You are 2 level of energy away. Okay, and that's the idea behind the noble gas configuration. You use the periodic table just to write a simplified, okay, electron configuration. This is another example. So one more time, atomic number of chlorine is 17. 17 AA is the number of proton, but if you have a neutral atom, you will have 17 electrons. How are you going to organize them? 1 S2, first level, 1 orbital. 2 S2, 2 P6, and you have 10, 3 S2, 10, 12, 3 P5. See, one more time, you're going to analyze the last level of energy, or the ending of the electron configuration. Chlorine is located in period 3, group. Now, since the ending is sp, you're going to add the electrons, 7, and put a 1 in front. In other periodic tables, group 17 is represented as 7A group. In YA group, because since the ending is sp, chlorine is a representative element. Transition elements, they are represented in the B group. See? So you add the numbers over here and you put a 1 or 7A, because the A means that it's a representative element. Questions about that? What other information, Ms. Ramos, can you find from there? Valence electrons. How many electrons on the last level of energy? Okay, you're going to add these two numbers over here. You're going to add these two numbers because those are the amount of electrons that are located on the last level of energies. 7. If that happens when you're working with transition metals too. For example, let me see, 22, titanium. Okay, let me put that over here. Titanium, atomic number equal to 22. So I'm going to start my first level, 2 electrons with 1 orbital. Second level, 2 electrons, my first orbital, a sublevel or subshell. P6, 3 with my S2, 3 with my P6, 4 S2, and I'm going to start counting. 1, 2, 3, 2, 4, 10, 12, 18, 20. I have 20 in there, so I need 2 more. Now I have 2 electrons. Oh my goodness, I make a mistake over here. Remember that you have, in the third level, you have 3 sub-levels. So you have your 3D2. Look at the ending. 3D2 is you want to organize using the level of energy first. 4S2. What is the information that you can get from there? Ending is in the D block, meaning that is a transition titanium, is a transition element. Transition element that is located in group 4. You don't have to put a 1 in front because it's not a representative metal. So you are going to add the electrons in there without putting a 1 in front, because you don't have a transition, you don't have a representative element. And how do you know that? Because you have a D subshell in there in the electron configuration. Group 4 is the group 4, and imperial 4. Because the last level of energy, that number that you have in front, the last level, the higher level of energy is giving you the period number. Okay? How many valence electrons? In this case, it's a little bit more complicated because you have hybridization that we are not going to touch that in chemistry. See, you're going to find, the valence electron only for representative elements. Like, Ms. Ramos, we understand all of that you're saying, but let's say that instead of knowing the atomic number of the element, we have a periodic table. What is the information that we can get from the periodic table? Simple. Okay, look over here at group 1. This group over here is the alkali metal group. If they are in group 1, it's because they have only one electron in the last level of energy. They are representative elements, so the ending of the electron configuration is 1s1. Ms. Ramos, are you telling me that all these elements that you have over here, they're going to have the same ending? It's not the same ending. Who's going to give you the difference? The period number. For example, the ending for hydrogen is 1s1 for the electron configuration. For lithium is 2s1. For sodium is 3s1. Potassium 4s1. And if you don't believe what I'm saying, just write that down. See, write the atomic number, follow the diagonal diagram, and you'll see. Beryllium is an alkali earth metal. In group 2, Ms. Ramos, what does that mean? That in the s orbital, it has only 2 electrons, 2 valence electrons, and the electron configuration is gonna end in the s orbital because group 1 and group 2, you have over there representative element. Are you telling me that all of them, they're going to have the same ending? No, the same ending as in group 1. The difference is the number that you have in front of the letter because they have different level of energy. For example, beryllium, the ending is going to be 2s2. Magnesium is going to be 3s2. Calcium is going to be 4s2. See that? Do you see the pattern in there? Now, the same is happening with other representative metals. You remember that the representative metal are group 1, 2, and 13 all the way through 18 now. But what happened with group 15 or 13 all the way through 18? 13, that the ending is going to be in sp. sp, for example, for group 13, it's going to be S2P1. Ms. Ramos, are you telling me that all these elements, they're going to have the same ending? The difference is the level of energy. Boron is going to be, let me see, 2S2, 2P1. But for aluminum, it's going to be 3S2, 3P1. And for gallium, it's going to be 4, 4s2, 4p1. See that? And that is a pattern that you're going to see on the periodic table. Okay? Periodic table. Across the periodic table. Now, Ms. Ramos, what's going to happen with the transition metals? Remember that this is going to end on the D block, and the ones that you have here at the bottom, they are going to end on the F block. Okay? Ms. Ramos, what's going to happen? Yeah, we understood all of that. We see the pattern that is in the periodic table, and we see how we can use the different endings just to find the valence electron, ending of the electron configuration to find the valence electron. But let's say that we have an element like radium, atomic number is 88. When we're talking about 2 electrons in one orbital, when we're talking about organizing 6 electrons in 3 orbitals, or 10 electrons in 5 orbitals, 88 is a big number, and we have to follow a lot of the arrows in the diagonal diagram. Is there a way that we can simplify the electron configuration for elements that has a high atomic number? There's a way that we can simplify that. Yes, see, you need a periodic table to do that. If we call that a noble gas notation. For example, for radium, atomic number equal to 88, you're going to locate that on the periodic table. It's over here in period 7, group 2. How are you going to write that electron configuration using a noble gas notation? Your first step is just to look at the noble gas that is in the period above. Okay, so period 7, I'm going to look for the noble gas that you know that the noble gases, they are located in group 18 or 8A, and you have radium. Okay, radium in there. So you're going to put over here between group inside the symbol for radium, and since over here, since radium is located in period 7, group 2, the ending is 7s2. You want to check that your word is correct. Look at the atomic number of radium. Radium atomic number is 86. Atomic number 86 plus the 2 that I have over here, 88, which is the atomic number of radium. And you're done. See? Simple. Simple and easy. Okay? Now, let's say, Ms. Ramos, for example, that you have iodine. How are you going to do that? Remember, you're going to look at the noble gas that you have in the period above iodine. Iodine is located in period 1, 2, 3, 4, 5. So you're going to look at the noble gas that is located, see? Period 5 that is located on period 4. You're going to start with that. Krypton in there. Krypton, you're going to put over here the symbol of krypton between grouping signs, and just in case that you want to check your work, you're going to put the atomic number underneath to check that your work is right. Now you're going to look for the position of iodine. Iodine is located 1, 2, 3, 4, 5, period 5, group 17 or 7A, meaning that the ending is going to be SP because it is a representative element. Since it's located in group 17, 2 in my s orbital, 5 in my p orbital, and the number that goes in front of the letter is the period number 1. Okay, so you go over here, 1, 2, 3, 4, 5. You're gonna put the 5 here in front of the S and the P. And then you're gonna check 36 electrons that I have in krypton plus 7 total over there, or 43. And the atomic number for iodine is 53. Ramo, we have a difference of 3 electrons. Of course, because you were omitting all this, see? All this part. Remember that that part is part of the D block. So what you are missing is your 4D10 in there. Okay? See how this works? This is the ending that is going to give you the group and the period number. What is missing in here is the level before that D orbital. And that's how we do that. Okay, let me show you another example to see if you understand this. Tellurium. Okay. Tellurium, no. I'm going to use polonium. Polonium It has an atomic number equal to 84. Polonium is located in group, let me see, group polonium is in group 16, period 1, 2, 3, 4, 5, 6. Okay, so polonium is located in period 6, group, what group? 16. Okay, because it's a representative element. So I'm gonna look at the noble gas that is in period 5. You need a periodic table for that. Xenon, atomic number equal to 54. Okay? Now, polonium is in group 16, SP, period 6, 2, 4. I have 6 in here. And when you add that, what do you get? 60. Is 60 the atomic number of polonium? No, it's 84. So I need 24 more electrons. How am I gonna end this electron configuration? I'm gonna start with my, see, lower below 5d10 energy that's below 5, 4f14. And I have over there my 84 electrons organized using a noble gas notation to write that down. Miramos, y what do you have over here? This 4f block, because when you look over here in the periodic table, see, polonium is all the way, let me see polonium, let me use another color. It's all the way here. And when you go back, see, at the beginning of that period, you have the F block affecting that. Yeah, I don't know if you have seen the pattern in there. See, this is the ending, last level of energy. But when you're writing the configuration, remember that, let me